everyone. So today let us take the binary classification programming exercise, and this is part of the crash course that we have been doing. So before this, there are two topics. Let us take this. This is a prediction bias. What is a prediction bias? It means that supposing a model trained on a particular data set has a 5% detection rate that a particular emails are spam. Now in the production, when it goes in the production or it does inference, it should be this 5% email, it should be same on average 5% of the email it classifies as spam. So that prediction bias, that what it has been trained on should reflect in the production, and it can be caused by noise in the data. And whenever it does not happen, that means there is some problem. And problem could be any of those things: noise in the data, bugs in the model type training pipeline, or set of features provided to the model being insufficient for the task. And next is the multi-class classification. So until now we have read the binary, and multi-class is more than one class. That is a multi-class. And one way to approach this is that we, supposing there are the three classes like A, B, C. So you label A and B into one class, and label C into another class, making it a binary class. Now let us go to the programming exercise. Yes. Yes. So Brian, here we have a rice data set. In this is the data sheet, and how we will approach this is, first is the libraries that are needed for this: matplotlib, numpy, pandas. These are the libraries that we need to install. And then there is a data set loading. Then we will describe the data, exploring, label and split, training the model, defining the functions, then plotting it, and evaluation against the evaluation set, then training the full featured with calculated metrics, third evaluation full featured model on validation split, comparing our two models, comparing final test. So this is the exercise. So let us go one by one. Disconnecting. I think it will take some time. And this data set is from a Turkish rice. This is from a classification of rice varieties using AI method, International Journal of Intelligent System and Application. And we will learn how to train a classifier, calculate metrics for binary classifier at different thresholds to compare AUC and ROC for two different models. And here we load the data set. Now this is load the import. Next one is the loading the data set. Once the data set has been loaded via the shell above, select the specific columns to show summary statistics of numerical features in the data set. Describe the data. What are the minimum and maximum length, major access length given the pixel the rice grains? What is the range of areas between the smallest and largest rice grains? How many standard deviations is the largest residence perimeter from the mean. To make experiments reproducible, we set the seed of the random number generator. This means that the order in which data is shuffled, okay, the value of the random weight initialization will be same each time the collab is run. Okay. Now next we have to load in the data set. Price data set raw pd dot read csv. I think we have loaded next to the Raj data set. Find okay, we did not load this. Yes. Data set we have modified. So these are the parameters or feature set. The data. This is the parameter major axis length, minor axis length, eccentricity. Now we will describe the data set. Now it's auto. Yes. The shortest grain is 145.3 pixels. Now let us explore the data set. It will create some graph. X-axis and y-axis 2D plots. 5 graphs will be created against each other. Area versus eccentricity. Axis length versus eccentricity. Okay, now we can name any of these in x-axis and let us say so this is the 5. This is in 2D. Now we'll plot in 3D. Let us take area versus eccentricity. Let us area versus center. Z-axis will be. Now one thing we are not explore, given time to explore is the data set, which we are currently doing. But what exactly is the data set is the rise. We need to understand the different features which we have not done. Perimeter. So this is why I am taking this random and exactly. There is an error. Let's see. It should match exactly what is the feature. That is what is happening. See, we uploaded in 3D. The earlier error which we were seeing was that the feature name, I think we were not spelling it correctly. So this is in 3D, this is the area, this is the eccentricity, this is the perimeter. plot major and minor axis, length and sensitivity observation. If you have to pick three features, it seems that major axis length, area, and sensitivity might contain most of that information that differentiate the two classes. Other combination may have as well. Run the previous code shell to grab those features if you haven't already. It seems like a distance class boundary appears in the plane of these three features. We will train a model on just these features, then another model on the complete set of features and compare them. Okay, we will train on first we will train on three features, then on all the features. Normalize data when creating a model with multiple features. The value of each feature could span roughly the same way.